Okay, thank you. So good evening all. Um, Yesterday we covered about the very important concept like the torsion of shaft and also thin cylinder and thick cylinder. So today the continuation of the strength of material that is we are going to cover today is one more important application in the strength of material is columns. Then we're going to take up after that plane stress, Moore circle. That is also very important concept that we're going to take up today. So columns, we'll talk about column first now. So let's talk about what is column first. So I think you know that what is columns. What is the purpose of column? What is the purpose of column? What is the purpose of columns? ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಕಾಲಮ್ಸ್?
Support the beam.
Hold weight.
Yes, support the beam as a structural weight. Usually columns is called a structural member. It is in a longitudinal section with there. It is a longitudinal section member. Longitudinal means the compared to the cross section, the length will be more. And it is always vertical in nature. They are going to place in vertical nature. So that will take up the act like a supports, especially in the building. They are going to use call it as pillars. Now here to design that, civil engineer going to use this concept called as columns in the strength of material. So that we are going to talking about now today. So columns and struts, structural members are subject to compression and whereas relatively long compared to its lateral dimension. So as I told you, lateral dimension means this one, okay? So this is usually this dimension is more, that means length is more. Relatively long compared to their lateral dimension, and that is called columns, or it's also known as struts. Generally, the term column used to denote the vertical member, and strut is denote the inclined member. In the column is there are one more name called as struts. So always columns maybe there always the columns will be placed like vertical only like this, whereas the struts is always placed like a either in a most of things like a inclined manner, or it may be like vertical also, but columns always preferred is vertical in nature. But that is the thing. And also in both these are structural member, and it will take up which kind of load. Which kind of load? So these columns take up which kind of load? Which kind of load?
Compression.
Hello? Always compressive, because the weight of the roof, anything, the structure will becomes towards the gravity. That will load will becomes on the take up by the these columns, okay, like this. So that is compression only, no tensile or any other things, only compression load comes under this. So in case of struts also it is same. Usually struts means you see in that in the building roofs like this will be there, especially in the corrugated sheet where they're going to place they're going to place like this structural member. This called a struts, okay? So now in the whenever the load is acting on this what is that on the columns, so there are three state of things we are going to observe here. One is called stable equilibrium and unstable equilibrium. What is stable and unstable means? Stable means a stable equilibrium is one in which body in static equilibrium on being displaced slightly and return to its original position and constant to remain equilibrium. So what is happens here now, the load is applied on this, so it is slightly going to be buckle like this, okay? It's going to bend. It's called buckling, okay? Here we call it as not bending, it's called buckling. Especially in beams, that when it is going to deform, no, that nature is called bending, but here we call it as a buckling, okay? So it is going to slightly, it is going to change its displacement, but when we again when you remove what happened, it comes to the original position, it returns back to original position. So this is called as stable equilibrium position. Unstable means it is in equilibrium is on which body in equilibrium being slightly disturbed and move away from its equilibrium position and lose state of equilibrium. So what is happens here, unstable means it's going to displace like that is buckle, it will going to slightly move away from its equilibrium position, So therefore, what is happens when it is bent buckle like this and more, it become like a unstable. So whenever the load is applied on this, and it is started to buckle continuously, what is happens here is it become unstable at one shot. It cannot withstand that load, and it's going to be collapse. So that is the things called as unstable equilibrium. Therefore, for a design things, for a not to for a carry the load, it should be always in the stable equilibrium condition. When it is reaches to unstable, it is may going to fail at any instant. The failure occurred very soon. That is the thing. So best example, like if you take a stick, okay, you take a stick, keep it on like in a vertical manner, you press on both sides in a hand like this, okay. So what is happens, it will bend, right? So if you started to apply the load, if slightly it will bend, and again if you leave it the load, it will come back. But when you started to press continuously, it started to bend more, and at any time it going to be break up. That is the things buckling will take place. So that is what here we talking about now, the load called as buckling load. The buckling load, it is also the load comes under this columns is called buckling load. That is the maximum load which can column can support before become to the unstable. The up to that unstable condition, what is the maximum load it can be carry withstand, or it can be resist that load. That is called buckling load. And one more, the name is called as crippling load, and another is called as critical load. So that means what is the maximum load it can be carried by the any columns, or it may be struts, till it reaches to the unstable condition. Because once it reaches unstable condition, it cannot be hold that load, and it may going to be fail or collapse. So that's the reason we talking about the maximum load capacity till it reaches to unstable. That called it as buckling load or crippling load or critical load. After that, what happened? The columns cannot be carry more than that load. So that is the things. So as I told you, always here the what you called a column will take up the compressive load, and because of the load that is compressive buckling load will be always in compressive nature. So therefore here that is because of the compressive load, which type of stress will be developed? Which type of stress will be developed? If compressive load in the what type of stress can be developed? Corresponding stress developed is called as what? Compressive stress. Okay. Obviously, there is a load is acting, means there will be stress will be up. Definitely, it's going to be act. At the stage, maximum stress in the column will be less than the yield stress. It is called crushing stress of the material. The buckling take place about the axis having minimum radius of gyration or least moment of inertia. So we're talking about here, as I saying here, at this stage, the maximum stress in the column will be less than the yield stress. So we call as crushing stress here. Basically, the pillars, maximum, the building pillar is made up of what? Which material? Which material? Maximum building is made up of which material?
Concrete.
So concrete structure, correct? Concrete structure. So and also it is also made up of a steel also. That is in case of the roofs. You can see that. So corrugated sheets, the building kind of called as what do you trusses. They made it in with the help of the columns will be made up of the steel and all. Okay. So now that is a here we're talking about crushing. The name called as in the particularly here called crushing stress. So crushing stress means whenever the load applied on the that columns, obviously stress will be developed. At particular one stage, what will happen? Stresses will goes to maximum, and when reaches that maximum stress, immediately it's going to be collapse, crush, because basically this concrete and all, it's a like a brittle in nature. What happens suddenly? It will be collapse, right? That's called crushing stress. Crushing stress is the critical stress. So when it reaches the crushing stress, it immediately going to be break up at any moment without showing any kind of the things like mm, uh, sign like ಬೆಂಡ್ ಆಗ್ತಾ ಗೊತ್ತಾಗಲ್ಲ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಎಲ್ಲಾದ್ರೂ ಕ್ರ್ಯಾಕ್ ಆಗಿ ಸಡನ್ ಫೇಲ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಸಡನ್ಲಿ ಕ್ರ್ಯಾಕ್ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್, ಇಟ್ ವಿಲ್ ಬ್ರೇಕ್ ಬಿಕಾಸ್ ದಟ್ ಇಸ್ ಅ ಬಿಹೇವಿಯರ್ ಕಾಲ್ಡ್ ಆಸ್ ductile it's not a ductile behavior, it's called brittle behavior. Brittle behavior ಅಲ್ಲಿ what is happens first suddenly it going to be crack will be form and it immediately collapse. Whereas in ductile ಏನಾಗುತ್ತೆ crack ಆದ ತಕ್ಷಣ fail ಆಗಲ್ಲ, it will prolong when it reaches to the critical length, then it will finally go to fail. But ಇಲ್ಲಿ ಹಂಗಲ್ಲ, it's suddenly it going to be collapse. So when is that it is happens means when it, the value the stress will be in the columns when it reaches to the crushing stress. So that is called crush. It will crush the pillar or columns, what we talk about. So as I told you, whenever the load is applying here on the any what is that columns, it's going to take a buckle action like this. This is called as buckling action. So now this buckling take place about the axis having minimum radius of gyration. I think we have discussed in the last two videos, that is in the beam concept, radius of gyration. Can anyone recall that what is the radius of gyration? What do you mean by radius of gyration? We discussed in a moment of inertia topic in the beams. Okay, correct? No? Can anyone recall what is radius of gyration? It's a very important physics concept. It's not a strength of material concept. Actually, it's a physics concept. Tell me. ಹೇಳಿದ್ನಲ್ಲ ಏನು? So it is the radius where the mass going to be, all the mass going to be concentrated. So what is that particular radius from the center with respect to that point where all the masses will be going to be concentrated? That is called as radius of gyration. It is denoted by letter what? It is denoted by letter what? Am I audible? Hello? Hello? Am I audible? Little denote ಮಾಡ್ತಾರಪ್ಪ. Hello? Am I audible to all? ಯಾವ ಲೆಟರ್ ಡಿನೋಟೆಡ್ ಮಾಡ್ತಾರೆ ರೇಡಿಯಸ್ ಆಫ್ gyration ಹೇಳಿದ್ನಲ್ಲ, ಕೆ. How to calculate the k? What is the equation? It is root of I by m. So where I is the moment of inertia, where m is the mass of. So here also that is very very important. So because what happens here, whenever it is the column is going to buckle, so what is happens? So at particularly one point, all the mass is going to be concentrated. Okay, that is called as the least radius of gyration. So the buckling take place about the axis having minimum radius of gyration. So ಎಲ್ಲಿ ಬಕ್ಲಿಂಗ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಎಲ್ಲಿ ಮಿನಿಮಮ್ ರೇಡಿಯಸ್ ಆಫ್ ಗೈರೇಷನ್ ಇರುತ್ತೋ ಅಲ್ಲಿ ಬಕ್ಲಿಂಗ್ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ರೇಡಿಯಸ್ ಗೈರೇಷನ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಬಕ್ಲಿಂಗ್ ಫ್ಯಾಕ್ಟರ್ ನ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಇಟ್ ವಿಲ್ ರೆಸಿಸ್ಟ್ ದ ಬಕ್ಲಿಂಗ್ ಆಕ್ಷನ್ ಇಯರ್. ದಟ್ ಈಸ್ ದ ಮೇನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆಫ್ ಕೆ ಇಯರ್. ಸೊ ದ ಮೇನ್ ರೋಲ್ ಆಫ್ ದ ಕೆ is here. It will resist the which action? It will resist the which action? Hello? It will resist the which action? Hello? I'm audible, right? Ashita? ನಾನು ಕೇಳ್ತಾ ಇದ್ದೀನಿ, ಕೆ ಅನ್ನೋದು ಯಾವ ಇದನ್ನ ರೆಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ? ಯಾವುದನ್ನ ರೆಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ ಇಲ್ಲಿ? ವಿಚ್ ಆಕ್ಷನ್? ಬೆಂಡಿಂಗ್ ಆಗುತ್ತೆ ಈ ತರ, ಏನಂತಾರೆ ಇದನ್ನ? ಬಕ್ಲಿಂಗ್. ಕೆ ಜಾಸ್ತಿ ಆದಷ್ಟು ಬಕ್ಲಿಂಗ್ ಎಫೆಕ್ಟ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸಿ ಇನ್ ದ ಲಾಸ್ಟ್ ವಿಡಿಯೋಸ್ ಅಂಡ್ ಆಲ್ ಯು ಕ್ಯಾನ್ ಸಿ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೇಕು. ಅದೇ ಹೇಳಿದೆ, ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏರಿಯಾ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಜಾಸ್ತಿ ಆದಷ್ಟು ಬೆಂಡಿ ಮೂಮೆಂಟ್ ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಅ ಒನ್ ಥಿಂಗ್. ಅದು ಒಂದು. ಮತ್ತೆ ಇನ್ನೊಂದೇನಂದ್ರೆ ಮಾಸ್ ಮೂಮೆಂಟ್ ಇನರ್ಷಿಯಾ ಜಾಸ್ತಿ ಆದಷ್ಟು ವಾಟ್ ಇಟ್ ವಿಲ್ ರೆಸಿಸ್ಟ್ ದ angular acceleration alpha. It will resist the it rotate ಆಗದಂಗೆ ರೆಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ. ಅದೇ ತರ ಇಲ್ಲಿ ಕೆ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ ಬಕ್ಲಿಂಗ್ ಎಫೆಕ್ಟ್ ನ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದೇ ತರ ಎಸ್ಟರ್ಡೇ ವಿ ಡಿಸ್ಕಸ್ಡ್ ಒನ್ ಮೋರ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಫ್ಯಾಮಿಲಿ ಇನ್ನೊಂದು ಯಾವ್ದದು ನಾವು ಯೂಸ್ ಮಾಡೋದು ಟಾರ್ಜನ್ ಅಲ್ಲಿ ಶಾಫ್ಟ್ ಅಲ್ಲಿ ಯಾವ್ದದು ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಫ್ಯಾಮಿಲಿ ಇನ್ನೊಂದು ಇದೆಯಲ್ಲ ಏನದು ಪೋಲಾರ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ. ವೆನ್ ದ ಜೆಪಿ ಇಸ್ ಇನ್ಕ್ರೀಸಸ್ ಏನಾಗುತ್ತೆ ಟಾರ್ಕ್ ಎಫೆಕ್ಟ್ ಟಾರ್ಷನಲ್ ಎಫೆಕ್ಟ್ ಏನಾಗುತ್ತೆ ಥೀಟಾ ಏನಾಗುತ್ತೆ ಆಂಗಲ್ ಆಫ್ ಟ್ವಿಸ್ಟ್ ಏನಾಗುತ್ತೆ ಆಂಗುಲರ್ ಟ್ವಿಸ್ಟ್ ಏನಾಗುತ್ತೆ ಜೆಪಿ ಜಾಸ್ತಿ ಆದಷ್ಟು ಇಟ್ ವಿಲ್ ರೆಸಿಸ್ಟ್ ದ ಆಂಗಲ್ ಆಫ್ ಟ್ವಿಸ್ಟ್. ಸೊ ಇದೆಲ್ಲ ಎಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್. ಅದಕ್ಕೆ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅನ್ನೋದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ ಯಾವುದೇ ನಾವು ಡಿಸೈನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ. ಸೊ ಈ ಕೆ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಇಲ್ಲಿ ಕೂಡ ಇಂಪಾರ್ಟೆಂಟ್ ಏನಕ್ಕಾಗುತ್ತೆ ಅಂದ್ರೆ ಬಕ್ಲಿಂಗ್ ಎಫೆಕ್ಟ್ ನ ಕಡಿಮೆ ಮಾಡುತ್ತೆ. ಸೊ ಎಲ್ಲಿ ಮಿನಿಮಮ್ ಕೆ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತಲ್ಲ ಅವಾಗ ಅಲ್ಲಿ ಬಕ್ಲಿಂಗ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ವಾಟ್ ದೇ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಹಿಯರ್, ಲೀಸ್ಟ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಆರ್ ಲೀಸ್ಟ್ minimum radius of gyration. Okay, understood?
Yes, sir.
So what is safe load? It is a load to which column subjected to and is well below the buckling load. Obviously I told you buckling load is a maximum load. It can be withstand or it is called critical load. But when we are designing a load with such a way that the load never reaches to the buckling, you should always the less than the buckling load. That is called safer load. So safer load will be the always the less than the buckling load or crippling load. It is also known as critical load. So now we in column ಅಲ್ಲಿ ಹಾಕ್ತಿವಲ್ಲ ಅದು ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಬಕ್ಲಿಂಗ್ ಲೆವೆಲ್ ಗೆ ರೀಚ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಗೆ ರೀಚ್ ಆಗಬಾರ್ದು. ಇಟ್ ಈಸ್ ಶುಡ್ ಬಿ ಆಲ್ವೇಸ್ ಸೇಫರ್ ಸೈಡ್, therefore it should be always less than that. So how to calculate this safer load? So again it is called as using a factor of safety. So you know all of you well about that factor of safety definition. What is a factor of safety definition? What is a factor of safety definition? Anyone? What is a factor of safety definition? It is a maximum load by safe load or working load. Maximum stress by working stress. Here I want safe load. Therefore safe load ಬೇಕು ಅಂದ್ರೆ maximum load by factor of safety. So maximum load by factor of safety. Maximum load andre it is nothing but buckling load here. So that is the way we are going to. So factor of safety is that is why we are going to choose that fact. So next is called stability factor. We are going to use the ratio of critical load to the allowable load. So how much critical load is there? That is what I said, critical load nothing but buckling load, that is P max divided by safer load. Safer load means this one, PS. This is nothing but stability factor. It is also called as factor of safety. That's all, nothing but factor of safety. So this is about the safe load and stability factor. Next we're talking about here. Here also like beam is going to be buckle like, it's like a bending action only. So here we bend beam also, it bend like there are two types of bending movement we discussed. One is called sagging and another one is called beam ಅಲ್ಲಿ ಒಂದು sagging, ಇನ್ನೊಂದು ಯಾವುದು ಈ ತರ ಬೆಂಡ್ ಆಗೋದು. What is that called as sagging bending movement. Same thing here also, like convex and convexity, it will be bent. The columns like this, concave and convexity like this. Whenever the column is bent like in a convexity, we consider as is positive. When it's concavity, it is negative. Same thing like here also, what we consider in the beams also. That is the things also we are going to consider the sign convention. So as I told you, the maximum load which carried by the any columns is called as buckling load. Then how to calculate that buckling load? There will be a derivations in the entire this column chapter in that strength of material. The final equation is called as like this, buckling load. It is also known as Euler load. So why it is called Euler means because Euler derived this. That's why it's called Euler load. So that is P is equal to pi square EI by L square. So you can see here. So pi square EI by L square, where E is the Young's modulus, I is the moment of inertia, L is the length of the what is that columns. So you can see the factor here, which are the factors which affect the crippling load, as you can observe here. So this is first always in the expression you have to see how which is directly proportional, which is indirectly proportional. That is nothing but inversely proportional, all those things. So P is directly proportional to what? P is directly proportional to what? P is directly proportional to what? Hello? ಈ ಈಕ್ವೇಶನ್ ಪ್ರಕಾರ ಪಿ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಯಾವ್ದಕ್ಕಿದೆ?
E and I.
ಈ ಆಸ್ ಯು ಯಂಗ್ಸ್ ಮಾಡಲ್ಸ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಕ್ರಿಟಿಕಲ್ ಲೋಡ್ ಕೆಪಾಸಿಟಿ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಕಡಿಮೆ ಆಗುತ್ತಾ?
ಜಾಸ್ತಿ ಆಗುತ್ತೆ.
ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಐ ಜಾಸ್ತಿ ಆದಷ್ಟು ಪಿ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸಿ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಜಾಸ್ತಿ ಆದಷ್ಟು ಕೂಡ ಆಗುತ್ತೆ ಇಲ್ಲಿ ಜಾಮೆಟ್ರಿಕಲ್ ಪ್ರಾಪರ್ಟಿ. ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ನಥಿಂಗ್ ಬಟ್ ಕೆ ಕೂಡ ಜಾಸ್ತಿ ಆದಂಗೆ. ಯಾಕಂದ್ರೆ ಕೆ ನಥಿಂಗ್ ಬಟ್ ರೂಟ್ ಆಫ್ ಐ ಬೈ ಎಂ ಅಲ್ವಾ? ಐ ಗೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ ಅದರಿಂದ. ಬಟ್ ಎಲ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ? ಎಲ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ?
ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ.
ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಈ ಲೋಡ್ ಬಕ್ಲಿಂಗ್ ಲೋಡ್ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾಕಂತಂದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ? ಈ ಎಲ್ಲು ಜಾಸ್ತಿ ಆಗ್ತಿದಂಗೆ ಬಕ್ಲಿಂಗ್ ಎಫೆಕ್ಟ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತಾ? ಎಲ್ಲು ಕಾಲಮ್ದ ಲೆಂತ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ? ಬಕ್ಲಿಂಗ್ ಎಫೆಕ್ಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಕಡಿಮೆ ಆಗುತ್ತಾ?
ಜಾಸ್ತಿ ಆಗುತ್ತೆ.
ಜಾಸ್ತಿ ಆಗುತ್ತಲ್ವಾ? ಇಟ್ ವಿಲ್ ಬೆಂಡ್ ಲೈಕ್ ದಿಸ್, ಇಟ್ ವಿಲ್ ಬೆಂಡ್ ಮೋರ್. ದಟ್ಸ್ ವೈ ಪಿ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ ಆಗ. ಸೊ ದಟ್ ಈಸ್ ದ ಥಿಂಗ್ಸ್. ಸೊ ಅಂದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು? ಪಿ ಗೆ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಇದು ಮೇನ್ ಇಂಪಾರ್ಟೆಂಟ್. ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಹಿಯರ್ ಆಲ್ಸೋ. ವಾಟ್ ಇಸ್ ದಟ್? ಯಾವುದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಇಲ್ಲಿ? ಇಷ್ಟರಲ್ಲಿ ಮೂರರಲ್ಲಿ ಯಾವುದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಇಂಡಿಕೇಟ್ ಮಾಡೋದು? ಹಲೋ, ಇಲ್ಲಿ ಮೆಟೀರಿಯಲ್ ವಿಚ್ ಇಸ್ ಇನ್ ದಿಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ವಿಚ್ ಇಸ್ ದ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ? ಕಾಣಿಸ್ತಾ ಇಲ್ವಾ? ಯಾವ್ದಿದೆ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಇಲ್ಲಿ? ಎಲ್ಲೂ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿನ? ಹಲೋ,
ಸರ್,
ಐ ಆಮ್ ಆಡಿಬಲ್? ಯು ಆರ್ ಆಲ್ ಇನ್ ದ ಲೈನ್, ರೈಟ್? ಡೋಂಟ್ ಬಿ ಕ್ವೈಟ್. ನನಗೆ ಇದಾಗ್ಬಿಡುತ್ತೆ, ಡೌಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಎಲ್ಲ ಕ್ಲಾಸ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದೆ. ನಾನು ಕೇಳ್ತಿರೋ ಕ್ವಶನ್ ವೆರಿ ಸಿಂಪಲ್ ಆಗಿದೆ. ಯಾವ್ದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ? ಇಷ್ಟು ಟರ್ಮ್, 3 ಟರ್ಮ್ ಅಲ್ಲಿ ಪೈ ಬಿಟ್ಬಿಡಿ, ಕಾನ್ಸ್ಟೆಂಟ್ ಯಾವುದು? ಇಷ್ಟೊತ್ತು ಬೇಕಾ? ಯಾವ್ದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ? ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಕೊಡ. ಇಷ್ಟೆಲ್ಲ ಮಾಡ್ಬಿಟ್ಟು ಏನಂತಂದ್ರೆ ನಿನ್ನೆಯಿಂದನೂ ಕೇಳ್ತಿಲ್ಲ. ಯಾವ್ದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ? ಈನ ಐನ ಎಲ್ಲ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ. ಏನ್ ಕಷ್ಟ? ಇ ಅಂದ್ರೆ ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ಲಿ. ಇ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಎ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ. ವಾಟ್ ಈಸ್ ಇ ಕಾಲ್ಡ್ ಆಸ್? ವಾಟ್ ಈಸ್ ಇ ಕಾಲ್ಡ್ ಆಸ್? ಇ ಅಂದ್ರೆ ಏನು? ಯಂಗ್ಸ್ ಮಾಡಲಸ್. ಯಾಕೆ ಇವತ್ತೆಲ್ಲ ಸ್ವಲ್ಪ ಡಲ್ ಆಗಿದ್ದೀರಾ? ಕಾಲೇಜ್ ಹೋಗಿ ಬಂದಾಗ ಎಕ್ಸ್ಪ್ಲೈನ್ ಆಗಿದ್ದೀರಾ? ಓ ಓಕೆ. ಬೇರೆಯವರೆಲ್ಲರಿಗೂ ಅದೇನಾ? ವಾ ಹರ್ಷಿತಾ, ಇವತ್ತು ಯಾಕೆ ಆಕ್ಟಿವ್ ಇಲ್ಲ ನೀನು? ಓಕೆ, ಸಿ ಇವಾಗ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ಸ್ ನ ರೀಕಾಲ್ ಮಾಡ್ತೀನಿ ನೋಡಿ. ಯಾವುದೇ ಬಾಡಿಲಿ ಆಕ್ಸಿಯಲ್ ಲೋಡ್ ಅಲ್ಲಿ ಆಗ್ತಾಗ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು ಎಫೆಕ್ಟ್ ಮಾಡೋದು, ಯೂಸ್ ಮಾಡೋದು, ನಾವು ತಗೊಳ್ಳೋದು? ಆಕ್ಸಿಯಲ್ ಲೋಡ್ ಇದ್ದಾಗ ಯಾವುದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್? ಯಾವುದು? ಆಕ್ಸಿಯಲ್ ಕಂಪ್ರೆಷನ್, ಆಕ್ಸಿಯಲ್ ಟೆನ್ಸೈಲ್ ಇದ್ದಾಗ ನಾವು ಯಾವ್ದನ್ನ ತಗೊಳ್ಳೋದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ? ಎಸ್ಟರ್ಡೇ ಐ ಟೋಲ್ಡ್ ಯು, ರೈಟ್? ವಿಚ್ ಇಸ್ ದಟ್ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಕಾಲ್ಡ್ ಆಸ್ ಇ. ಅದೇ ತರ ಬೀಮ್ಸ್ ಅಲ್ಲಿ ಟ್ರಾನ್ಸ್ವರ್ಸ್ ಲೋಡ್ ಇದ್ದಾಗ ಯಾವ್ದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಬರೋದು? ಯಾವುದು? ಯೂಲರ್ ಇಕ್ವೇಶನ್ ಪ್ರಕಾರ ಅಲ್ಲೂ ಕೂಡ ಈನೆ. ಅದೇ ತರ ಎಸ್ಟರ್ಡೇ ವಿ ಡನ್ ಟಾರ್ಷನ್, ಅಲ್ಲಿ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು? ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು ಅಲ್ಲಿ ಬರೋದು? ವಿ ಆರ್ ಕನ್ಸಿಡರಿಂಗ್ ವಿಚ್ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಮೇನ್ಲಿ? ಇಟ್ ಇಸ್ ನಾಟ್ ಇ, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಜಿ. ಬಟ್ ಇಲ್ಲಿ ಕೂಡ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು? ಈನೆ. ಅದೇ ತರ ಇಲ್ಲಿ ಜಾಮೆಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು? ಏರಿಯಾ. ಅದೇ ತರ ಬೀಮ್ಸ್ ಅಲ್ಲಿ ಜಾಮೆಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು? ಏರಿಯಾ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ. ಅದೇ ತರ ಟಾರ್ಷನ್ ಅಲ್ಲಿ ಜಾಮೆಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟಿ ಯಾವುದು? ಪೋಲಾರ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ. ಇಲ್ಲಿ ಯಾವುದು ಜಾಮೆಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟಿ? ಈಗ ಜಾಮೆಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟಿ ಮೇನ್ಲಿ ಯಾವುದು?
I.
These are things very important. Okay, so in the entire uh, column design, there are end conditions of the columns are very important. There are mainly four conditions of the columns in there in practical application. One will be one end will be fixed and other end is free like this. One end is will be fixed and other end is free. And next there is a second end condition is both the ends are hinged or pinned. ಎರಡು ಕಡೆನೂ ಇಂಜ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಪಿನ್ ಮಾಡಿರ್ತಾರೆ. ಅದನ್ನ ಬೋತ್ ಎಂಡ್ಸ್ ಆರ್ ಪಿಂಡ್ ಅಂತ ಕರಿತೀವಿ. ಇನ್ನೊಂದು ಕಂಡೀಷನ್ ಹೇಗಿರುತ್ತೆ ಅಂದ್ರೆ ಒನ್ ಎಂಡ್ ಇಸ್ ಫಿಕ್ಸೆಡ್ ಅಂಡ್ ಅದರ್ ಎಂಡ್ ಇಸ್ ಇಂಜರ್ಡ್ ಲೈಕ್ ದಿಸ್. ಥರ್ಡ್ ಕಂಡೀಷನ್ ಇಸ್ ಬೋತ್ ಎಂಡ್ಸ್ ಆರ್ ಫಿಕ್ಸೆಡ್, ಬೋತ್ ಎಂಡ್ಸ್ ನ ಫಿಕ್ಸ್ ಮಾಡಿರ್ತಾರೆ ಅಂಡ್ ಲೋಡ್ ಇಸ್ ಅಪ್ಲೈಡ್ ಅಟ್ ದಿ ಟಾಪ್ ಆಲ್ವೇಸ್. ಸೊ ದಿಸ್ ಆರ್ ದ ಫೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ end condition will comes in the any columns in a practical way. ಈಗ ಬಿಲ್ಡಿಂಗ್ ಅಲ್ಲಿ ತಗೊಂಡಾಗ ಔಟ್ ಆಫ್ ದಿಸ್ ಫೋರ್ ಅಲ್ಲಿ ಯಾವ ಎಂಡ್ ಕಂಡೀಷನ್ ಬರುತ್ತೆ? ಬಿಲ್ಡಿಂಗ್ ಕಾಲಮ್ಸ್ ಅಲ್ಲಿ ಬಂದಾಗ ಯಾವ್ದು ಬರುತ್ತೆ? ಔಟ್ ಆಫ್ ದಿಸ್ ಫೋರ್ ಅಲ್ಲಿ ಬಿಲ್ಡಿಂಗ್ ಕಾಲಮ್ಸ್ ಎರಡು ಕಂಡೀಷನ್ ಯಾವ್ದು ಬರುತ್ತೆ? ಒಂದ್ ಕಡೆ ಫ್ರೀ ಕೊಟ್ಟು ಒಂದ್ ಕಡೆ ಫಿಕ್ಸ್ ಮಾಡಿರ್ತಾರಲ್ಲ, ಒಂದ್ ಕಡೆ ಎರಡು ಕಡೆ ಇಂಜ್ ಮಾಡಿರ್ತಾರ, ಇಲ್ಲ ಒಂದ್ ಕಡೆ ಫಿಕ್ಸ್ ಮಾಡಿ ಒಂದ್ ಕಡೆ ಇಂಜ್ ಮಾಡಿರ್ತಾರ, ಇಲ್ಲ ಎರಡೂ ಕಡೆ ಫರ್ಮ್ ಫಿಕ್ಸ್ ಮಾಡಿರ್ತಾರ. ಸೊ ಫೋರ್ತ್ ಕಂಡೀಷನ್ ಜಾಸ್ತಿ ಬಿಲ್ಡಿಂಗ್ ಗೆ ಯೂಸ್ ಮಾಡಂತದ್ದು. ಓಕೆ, ಸಿ ಆಲ್ ದೀಸ್ ಫೋರ್ ಕಂಡೀಷನ್ ಏನಾಗುತ್ತೆ, ದ ಕಾಲಮ್ಸ್ ವಿಲ್ ನಾಟ್ ಬಿಹೇವ್ ದ ಸೇಮ್. ಇಟ್ ವಿಲ್ ಬಿ ದ buckle will be different for different end condition. So therefore different end condition mele load carrying capacity also it will going to be vary. So this therefore what is a crippling load for each case? We know general case for P, this is the equation, but according to the end condition what is the P become? So there is a end conditions here we are going to use, that is called, here we talking about only the end condition will be not E will be changed, not even I will be, only change will be the length of the beam, that is called effective length. So when both ends are hinged, there is LE equal to length of the beam will be there, and when one end is fixed other end is free, yes, the equivalent length is 2 times of the length of the column will be there, and when one end is fixed other end is pinned, LE equal to L by root 2 will be there, and when both ends are fixed L equal to L by 2. So in place of L, if you substitute this here, you will get the Euler load or crippling load for different end condition equations, this one. So these all are four important derivations will be there in the strength of material on this topic, but anyway we are going to refer only the final expressions. So when you are designing the any column, the designer should know first what is the end condition. Based on that he has to use this equation to carry the what is the maximum crippling load or buckling load, it can be comes under that particular columns. So based on this end conditions, keep this in mind. End conditions are very important in the entire columns. Okay, hello. Okay, so basically in the columns there are where they classified as actually one is long column, another one is the short column. Okay, based on the length they are going to classify the long column and short column. So long column is usually the length will be more, short column is usually the length will be less. So what is happened in the long column, usually it will fail by a buckling like this, whereas short column ಅಲ್ಲಿ buckling effect ಕಡಿಮೆ ಇರುತ್ತೆ, ಲೋಡ್ ಆಗ್ತಿದಂಗೆ ಏನಾಗ್ಬಿಟ್ವೆ it will be going to fail by a crushing action, like as I told you in a pillar case, ಲೋಡ್ ಆಗ್ತಿದಂಗೆ crush ಆಗ್ಬಿಡುತ್ತೆ. So that is called short column, that is called short column. Okay, so suppose you take a brick like this, that is like act like a short column, vertical place ಮಾಡಿದ್ರೆ ಅದ್ರ ಮೇಲೆ ಲೋಡ್ ಆಗ್ತಿದಂಗೆ ಏನಾಗ್ಬಿಡುತ್ತೆ ಸಡನ್ ಆಗಿ ಕೊಲಾಪ್ಸ್ ಆಗುತ್ತಲ್ಲ, ಅದು it is failed by due to crushing action, it is failed due to the buckling action. So these are the basic difference in the two types of columns, one long column ಇನ್ನೊಂದು short column. ಲೆಂತ್ ಮೇಲೆ ಇದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತಾರೆ. ಸೊ ಲಾಂಗ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಯಾವಾಗ್ಲೂ ಫೇಲ್ ಯಾವ ತರ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಬಕ್ಕಲ್ ಆಗುತ್ತಲ್ಲ, ಆ ಬಕ್ಲಿಂಗ್ ಆದ್ರೆ ಫೇಲ್ ಅಂತ ಅರ್ಥ. ಯಾಕೆಂದ್ರೆ ಬಕ್ಲಿಂಗ್ ಅದು ಬೆಂಡ್ ಆದ್ರೆ ಕ್ಯಾನಾಟ್ ಬಿ ಟೇಕ್ ಅಪ್ ಲೋಡ್, ಫೇಲ್ ಅಂತಾನೆ ಅರ್ಥ. ಬಟ್ ಶಾರ್ಟ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಲೋಡ್ ಆಗ್ತಾಗ ಬಕ್ಲಿಂಗ್ ಎಫೆಕ್ಟ್ ಕಡಿಮೆ, ಬಟ್ ಇಟ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಗೋಯಿಂಗ್ ಟು ಬಿ ಕ್ರಶ್. So what we seen here, the long the maximum load equation called as crippling load. It is old school for long column. Euler ಏನ್ ಮಾಡ್ದ, is work on the long column. So then the person, the work on the short column is called as Rankine. So the Rankine, what he done is, so he derived the equation. Mainly it can the things for the short columns. So for that, you are going to derive the equation, that is P is equal to sigma C by A 1 plus A into LE by K whole square. So using this, we can able to calculate what is the short column can carry the maximum buckling load using this equation. So where sigma is the crushing stress, A is the area, L is the length, K is the radius of gyration, where A is called as constant, Rankine constant. This Rankine constant, it is depend upon the different material. That value you can see in this chart. Cast iron ge, wrought iron ge, mild steel, aluminum ge, timber ge. What is the value of this A value? A is called Rankine constant. He derived this equation. It is old school for short column, whereas Euler equation, it is old school for long column. So this is about it. Is it? So have you got it? Hello, everyone. All of you understood? All of you. All of you. You are there?
Yes, sir. Yes, sir.
Okay.
ಇದೀವಿ.
The thing is, this is the main important, these two concept, it is only comes under this column. By this we are concluding the columns. Okay, that means we are taken in the strength of material very important three application. One is beams,